Okay, now you can work this out just using your calculator. If you look, the first one here, function 2x, the 2 timesing by 2 is inside the function. So your y equals f of 2x is going to equal, if you were to put this into your calculator, 2x cubed minus 3 times 2x minus 2, and then see what that comes up with. You can find that turning point, that point there, that turning point, that point there. You can see exactly what's happened to it, and you don't have to do any working out. However, if you don't, then it's not actually that difficult. You just need to think about what's going on. And because it's inside the function, that means it's going to affect the x coordinate, and it's going to affect it by the opposite way than you'd expect. So rather than doubling, it's going to halve. So it's a stretch of stretch of multiplied by 1/2. So my a here, it's negative 2, 0. Sorry, no, it's not. That's negative 1, 0. So my point A is going to become negative 1/2 and 0. My point B, at the moment, that's 0, negative 2. So when it's 0, you halve 0. That's still going to be 0, negative 2. So B doesn't move. C is going to be multiplying, that point there is 1, negative 4. So the y value is not going to change. That y value is going to happen when x is only 1/2. And your d is going to be, your y value is 0. That's going to happen when your d is only half of 2, which is 1. So then we just need to replot that curve. So there's 1 and there's 1/2. So, and we can write down negative 1/2, 0. We know it's going to plot there. That's A. Then we've got B, exactly the same place. So B equals 0, negative 2. We've then got C happening at when x is 1/2. So that is going to be, and that's going to be negative 4, isn't it? So that's going to be 1/2 negative 4 is equal to C, and then D is happening when it's 1, so that is 1, 0 equals D. And then we just sketch our graph in like that, so it's just doing the same thing, something like that. It doesn't have to be brilliantly done, but those points need to be shown clearly. When it comes to the second one, part B, function of negative x, well, every x value is going to be changed to the negative to get the same y result. So when my x value is 1, instead of getting what will get me, when my x value was 1, well, it will be reversed to negative 1. That's going to get me negative 4. So going through the same process over here for y equals minus f of minus x. So my a value, instead of being negative 1, my x value becomes 1. My y value is the same. This is going to give us our reflection in the y-axis. When it's 0 is still 0, isn't it? So that's still going to get me the negative 2. For C, I'm going to get my negative 4 by timesing that by minus 1, so that's minus 1, and I'm going to get my D, my value of my y value of 0, when my D value is the negative of 2, which is negative 2. And then I'm just plotting those points before I sketch that curve in. So what have we got there? We've got 1, 0, and we know that's A. We've got 0, -2, 0, -2 equals b. We've got -1, -4 is going to be about down there. -1, -4 equals d. So that's, sorry, that's not d, is it? That's c. And then we've got at -2, we've got our d being there. So once we've got those 4 points, we can just sketch that in. And just glancing across there to see how similar that is. Okay, one question left.